And we are given that the diameter is 1.5. Okay, change to radius. So this will be equal to 1.5 divided by 2 squared times shift 5 equal to 60 power 3 divided by. It's going to minus, okay, go on. Yeah, minus 33, wait, divided by 2 squared shift 5. Hold on, I'm having problem pressing calculators today. $33.953 minus 33.953 times by 10 to the power 3 psi. So we know that stress X is equal to 0, right? So now we can determine the center of the circle, which is equal to stress average, and this will be equal to minus 33.953 times 10 to the power 3 plus by 0 the whole thing divided by 2. So this is equal to minus 16.977 times 10 to the power 3 psi. That we know. So the next thing that we're going to do is we are going to find our, sorry, what am I talking? We know the diameter, we don't know the torque. I do apologize. Okay, I thought we are asked to find the size of the shaft. It's not. We have tasked to find the torque. I do apologize. Okay, so we know that this is our center of our circle. Okay. So now if we are trying to identify stress A and stress B now. Okay. So we know stress A and stress B is equal to stress average, right? Plus or minus R. So R is the radius of the in plane circle, and is also equal to our tau max, right? The tau max is the maximum, as you can see from our mole circle, right? The biggest circle is the in plane, right? So from here to here, we can see that it poses the largest circle, right? So this is our tau max. Okay. So from here, we just write out the equation first. Okay. So if we look into Bomis's criteria, we have stress A squared minus stress A, stress B plus by stress B squared, okay, must be less than stress U squared. Okay. So if you look at stress A, right? So stress A is stress average plus R, okay, squared. Let me do some side work over here. So note that stress A is equal to stress average plus R, and stress B is equal to stress average minus R. Okay, let me define that. So now we just do a method of substitution. Okay. And then when we expand the term, Okay, you got this representative. So what we can do is we can get rid of this term over here. We can get rid of this term over here, right? So stress average, right? You can get rid of this, and get rid of this, right? But you still have one stress average squared left. So at the end of the day, we will have stress average squared, right? Minus, you have plus 1, 2, 3 plus 3r squared. And this thing will be equal to stress u squared. So to find the radius now, we have to find the radius. Okay, we have to find what is our r. Okay, so the radius of our circle, right? So if we were to go back to mole circle, right? So we are trying to find the average at what we have over there. Okay. So the radius of the circle will be square root of our stress. Then we have calculated stress average squared. Okay, stress average squared minus. Oh, I'm having a bit of brain not functioning today. Chatting most. Wait. What am I doing? I think I skipped steps. So we're going to find the radius. Pardon me. Okay, I'm sleeping today. So from here, we know that 3r squared is equal to stress y squared minus by stress average squared, right? So we are going to find what is our radius. Okay. So this is equal to stress u squared minus stress average squared divided by 3. So our r is equal to stress u squared minus by stress average squared divided by 3. Okay. So now we can find our what? Our radius. Okay, so now we can find the radius of our mole circle. Now, let's calculate the value first. Okay, then let's see why should we determine the radius. Okay, let's do this first. Okay, so this will be equal to, because I don't want to confuse you guys, all of us. Okay, so we are aware that the yield, cannot remember now, is equal to 42 times 10 to the power 3 squared minus by your stress average, which we have found earlier, which is equal to 16.977. Then the whole thing divided by 3. Okay. So this is equal to 42 power 3 squared minus by 16.977 power 3 squared divided by 3, square root the whole thing is equal to 22.179 times 10 to the power 3 psi. So what are we trying to determine down here? Okay, so let me bring over the mole circle that we have constructed, and let me bring this over. Because if we don't draw the mole circle, it gets difficult to visualize. Okay, so hopefully this will help you visualize better. I know it will, because it helped me a lot. Right. So what we are trying to determine now, okay, is we are trying to determine what is our shear xy. We don't know what it is. Okay. We have already found that our stress average over here, we already identify that the distance from here to here we have already identified that the distance from here to here, or either one, this is equal to, what do we calculate it to become? Our stress average was 16.977. Likewise, is 16.977. So we are trying to identify what's our shear, right? So by applying, so how we get this R over here is by using von Mises criteria. Okay? And we found that the R over here is this distance over here. Okay. So this is our radius, R, which is equal to 22.179 times 10 to the power 3, right? So from here, we can find, right? We can find this height over here. We can find this height over here. So this height over here is our shear xy. So once we can find our shear xy, we can relate to the torque. Okay. So shear xy is straightforward. No need to memorize any formula. High school math for now. So shear xy is equal to square root of 22.179 bracket 22.179 times 10 to the power 3 squared plus or minus, pardon me, 16.977 times 10 to the power 3, the whole thing squared. And then not finally yet, we have 22.179 power 3 squared minus 16.977 power 3 squared equal, then you square root the whole thing, it's equal to 14.272 times 10 to the power 3 psi. And then, you know, we now can determine the applied allowable torque. So we know that this will be equal to Txy is equal to Tc over J, or Tr, or what do we call the radius earlier? Yeah, I'll call it R radius. Okay. So this will be T is what we are trying to determine, R over, so this is pi over 2, and this is R to the power 4, and the whole thing is equal to 14.272 times 10 to the power 3. Okay. So we can cancel our radius to become cube. So our torque is equal to 14.272 times 10 to the power 3